Hello everyone, welcome back. In this lecture, we are going to watch a short video that is going to explain the difference between distance and displacement. Now, I know that we have already established that distance is a scalar quantity and that displacement is a vector quantity, but we want to dive a little further in, okay? We want to go a little deeper. I would hope that if you were asked to determine a distance or a displacement based on a schematic, you could do so easily. And this video is really going to explain how, so we can make sure that we're all on the same page regarding the difference between distance and displacement and really what that looks like logistically. So I'm going to go ahead and get the video started. So just bear with me for a second.
What is the difference between distance and displacement? Do you know the difference? Well, there's a big difference between the two, and it's important to understand it. The reason it's important to understand is that these two words come up all the time in the study of kinematics.
Okay, so let's pause that video for just a second and let's talk about kinematics. What is kinematics, all right? You may want to know the definition. You may see it again. All right, kinematics is essentially a branch of mathematics that deals with pure motion without reference to the masses or forces involved in it. And that definition of kinematics is coming from dictionary.com. Okay, I went ahead and looked that up for you. All right, now let's get back to our video.
So in order to understand this, let's just take a look at some examples. Let's first of all take a look at some examples of distance. Let's suppose that you start at point X. We'll call that point X. That, by the way, has a name. That starting point has a name. It's called the origin. And we're going to start at the origin, point X, and we're going to ride a bike or some other mode of transportation all the way over here to point Y. And we're going to stop at point Y. If I were to ask you, what is the distance that you traveled? You might have measured the distance, and you might say, well, between point X and point Y, I know I traveled 10 kilometers. And that is the distance between point X and point Y, 10 kilometers. Well, 10 kilometers, that is a scalar measurement. So the first thing you want to remember about distances is that distance is a scalar measurement. It does not have a direction. Distance does not have a direction. It's a scalar measurement. And it is simply the length of the path traveled between the origin, your starting point, and your ending point, in this case, at point Y. So I could say here that the distance I traveled was simply 10 kilometers. Well, let's take a look at another situation. Let's suppose, again, you started at point X, our origin, and you traveled all the way to point Y, right there. Then you turned around and you came halfway back and stopped right there. We'll call that point Z. If you stop here at point Z, the distance that you traveled, the total distance that you traveled was 10 kilometers to Y and 5 kilometers halfway back to X. Z places you at a total distance of 15 kilometers. Why? Because that is the total length of the path that you traveled between the origin and your final destination, which was point Z. So the distance you traveled was 15 kilometers. Now let's take a look at a third situation. Let's suppose that you started at point X again, and you traveled all the way over here to point Y. That was a total, remember, of 10 kilometers. And then you turned around and you came all the way back home again to point X, to your origin. And that trip gave you a total of 20 kilometers round trip. The distance that you traveled was equal to 20 kilometers, the round trip distance. Okay, let me throw another situation at you. What if you started here at point X and you walked through the woods on this path, which was very curvy, very convoluted, it wasn't a straight path, and you came all the way back here to your origin right there at point X. You came right back home again. Now, if you measured the length of that path around all these curves right through the woods here, you might find out that the total distance that you traveled was perhaps 20 kilometers, whatever it was. Distance, by definition, simply put, a simple definition, distance is the total length of the path that you travel from your origin to your final destination or stopping point. It is the total length of the path traveled. That's distance. And distance is a scalar measurement. Going back to the previous lesson, remember that distance is a scalar measurement because it has a quantity and a unit of measurement. That's all it has. That makes it a scalar measurement. So distance, here's what you want to remember, is the total length of the path traveled from the origin to the ending point, and it is a scalar measurement. Now let's take a look at displacement. And we'll use the same scenario each time. So in the first scenario, we started at our origin, which was point X, and we traveled all the way over to point Y. And that was a distance of 10 kilometers. But the displacement is not just 10 kilometers. The displacement, in this case, is 10 kilometers east. Displacement, unlike distance, is a vector measurement. It is a vector measurement. That's important. It is a vector measurement because it not only includes a quantity and a unit of measurement, but it also includes a direction, in this case, east. And you'll notice right over here, I have a small compass rose over here. It shows you north is towards the top of this page, south is towards the bottom, east is to the right, and west is to the left. So, displacement will always include either a stated direction or an assumed direction. So if I said somebody has a displacement of 10 kilometers, then you have to just assume, even though I didn't tell you what it was, that there's a direction there somewhere. So let's take a look at some other situations. This first situation, the displacement was 10 kilometers east. In the second situation, we started at X, and we traveled all the way over here to Y. And we turned around and we came halfway back. Now, if we look at the distance is a total of 15 kilometers. But the displacement, when you reach this point, point Z, right here, when you reach point Z, your displacement is not 15 kilometers. Your displacement is equal to 5 kilometers east. And you might say, well, why is that so? Well, it's the real difference between distance and displacement. Your displacement is the straight line, distance and direction between the origin, your starting point, and your ending point. So this red line represents your displacement, and that displacement is 5 kilometers east of the origin where you started. That is really the difference between distance and displacement. Distance is simply the length of the path that you traveled, where displacement is the straight line, distance and direction between the origin and your final ending point. So let's take a look at this third example down here. we started at X and we traveled all the way to point Y. And then we turned around and we came all the way back home again to our original origin. And when we did that, the distance we traveled over here on the left, the distance we traveled was a total of 20 kilometers. That would be from X to Y is 10 kilometers, and from Y to X back again is another 10 kilometers. So the distance was 20 kilometers. However, our displacement is now 0. Why is it 0? It's because we are back at the original point and we are not displaced from that origin. Displacement, going back to the definition, is the straight line distance and direction between the starting point, the origin, and the ending point. And the straight line distance and direction between the starting point and the same point where you end is now going to be 0. So the displacement is 0 in this situation. All right, let's take a look at this next example down here. We walk this curved path. And I won't redraw this path, but let's take a look at this. If we look at the distance that we traveled along this curved path over here, we traveled a total distance of, I said, 20 kilometers. But since we came all the way back to the original origin, our original starting point, the displacement is equal to 0. Why is it 0? Because displacement is the straight line distance and direction between the starting point and the ending point. Another way to say this is displacement is how far you are displaced from the origin. How far and in what direction you are displaced from the origin. So, in the first situation up here, let's take a look at these 3. In this first situation, your displacement is 10 kilometers east because you are displaced 10 kilometers east of the origin. In the second scenario, you are displaced 5 kilometers east of the origin. And in the third situation down here, because you came all the way back to your original starting point, your origin, then you are displaced 0 kilometers from your origin. And that is the difference between distance and displacement. Distance is a scalar. Displacement is a vector measurement. Why? Because a vector measurement, like displacement, has both a magnitude and a direction.
Okay, so that kind of wraps up the video, or at least the portion of the video that I wanted you to see. And now let's see if we can apply what's been said, just to make sure that you understand and can easily calculate or make a determination as to what the distance is and what the displacement is, okay? So again, I'm going to ask for that artistic license, that it be granted. And give me just a second to pull up a color we can see here on the board. All right, so we're going to pretend that you start out at point X. All right, you're at point X, so X is the starting point, and you travel a straight line path. And we're just going to say that that straight line path is 20 kilometers. From point X to point Y. All right. And let me just do a little compass here so that we know our directions. Oh, it's not letting me write it there. All right, so there's our little compass rose. So you're going to travel east from point X, 20 kilometers to Y, all right? And then when you get to Y, you're going to turn and travel south 10 kilometers. To point Z. And then when you get to point Z, you're going to turn and travel back west 20 kilometers to point Q. All right, so X is your starting point and Q is your end point. I'm going to go ahead and just highlight those little points. So we've got X as our starting point, and then we travel from X to Y, from Y to Z, and end up at Q. So our entire trip is from X to Q, all right? From X to Y to Z to Q. So now what I want for you to do is see if you can quickly make a determination as to what distance has been traveled, okay? So let's see, the distance, remember the distance is simply the length of the path traveled. So what is the distance? So we've got 20 kilometers, and then we traveled 10 kilometers, and then another 20. So in all, the distance you should have come up with is 50 kilometers, correct? And now we do not need to include a direction, only a numerical value and its associated units for distance, okay? So that's the magnitude or the size of the path traveled, all right? The length of the path traveled is our distance. And then I want you to tell me, what is the displacement? So if you travel from point X to Y to Z and end up at your final destination of Q, what is the displacement? And you should be able to determine, remember, based on what we just heard in the video, it's the straight line path from the origin to the final destination. So that would be this path here. So the displacement is really along that dashed line, all right? And so what we can say is we were displaced when we traveled that distance, and in the path that we did, we end up being displaced from our original position 10 kilometers to the south. Okay? So hopefully you came up with that answer as well. All right, I think that is about all we need to differentiate these two, and hopefully if you see this again, you could easily determine the distance and displacement on your own.